Hi there, physical science students. I'm going to talk to you today about chemical properties, the third section of chapter 2. And these are actually some of the most interesting things that we're going to be looking at in this semester. And honestly, from here on in, we are going to be starting to talk about chemical reactions. And the only way that chemical reactions occur is if the materials in question have certain properties that allow them to interact with other things. And so some examples of those chemical properties would be the ability to burn. Anything that's flammable, flammability is definitely a chemical property. There are materials that resist burning, and there are materials that burn very, very easily and in a very rapid fashion. So flammability is one of the properties we'll look at. Ability to tarnish. On the left-hand side here in this picture, you can see a silver spoon that has begun to tarnish. And this is a very common problem when people store their silver. They don't always use their really good silverware for every day, but they might put it in a box and take it out at holiday time and find that there is tarnish. And so then they have to polish it and clean it up before it gets used again. Well, this tarnish is actually the silver that is on the very, very surface of the silverware. It's the atoms that are right on the very outermost surface of those layers, and they interact with actually sulfur in the air. And that brown, blackish, dusty stuff that builds up is actually silver sulfide. So ability to tarnish is a chemical property. Rusting and decomposition, both of those, generally rust involves interacting with the oxygen in the air, and then decomposition would be a variety of kind of interactions. When we think of decompositions, we oftentimes think of like maybe living things like a leaf falling off a tree and then decomposing, eventually returning to the very elements that are in it and going into the soil. Um, the ability of a material to react with anything else known as reactivity. That would also be a chemical property. This list is not all inclusive, but it gives you an idea of what we're talking about. So when we think of these chemical properties being illustrated, one of the things you want to remember is that chemical changes are only observed if the material changes into something entirely different. So unlike our physical changes, in a chemical change, you have a whole new substance that results. So an example on this slide with some of these pictures. Eggs. When we cook an egg, we change the proteins in that egg. The proteins that are in the egg, for example, the one that makes the egg white, the way that you see it, that's known as albumin. And when you heat it up, you cause the bonds in those proteins to change, and you can't reverse it. You can't uncook an egg. You can't unbake a cake. The burning of wood, you end up with ash and then some smoke that goes off into the atmosphere that is water vapor with a little bit of that ash connected to it. So it's important to remember that in a chemical change, what you started with is quite different than what you end with, and you want to always remember that. So when we are looking at a chemical change, there are some things that we want to observe that would tell us that a chemical change took place. So one of the things that you want to look at is, was a gas given off? If a gas was given off, you're going to see bubbles. The other thing is, if there is a precipitate, precipitates form when you have two solutions that you put together and all of a sudden you get a solid dropping to the bottom of the vessel that you've got those two solutions in. It's a solid there. If there's bright light or flames or heat being given off during the course of a chemical reaction, you can pretty much conclude that there was a dynamic change that created that. The other thing is that you might see a color change, but it is extremely important to know that color change is one that you can actually see color changes sometimes in a physical change as well. So you want to make sure you're thinking about this. Did the material change into a completely different material before and after? If the answer is no, then there wasn't a chemical change. If the answer is yes, then there was. All right, so back to the review here from the very beginning. We started talking about matter. We talked about the different forms of matter and the states and the changes between those. Pure substances were the elements and compounds, and we're going to talk about these when we talk about chemical reactions, and then the mixtures, the homogeneous and the heterogeneous mixture. I just wanted to take a quick review of some of those initial concepts. This is a good picture to look at when you're trying to make the distinction. Am I looking at a compound, which involves chemically combined things, or am I looking at a mixture? Big thing, a compound has a fixed composition, there are chemical bonds, and it can only be separated by a chemical means, a chemical change. If it's a mixture, the composition varies, it's not consistent throughout, there are no chemical bonds between the components in the mixture, and it could be separated by physical means. Okay, so just some things to think about. Thinking about properties. Why does every sample of a given pure substance have the same properties? Think about why the composition of an element is fixed. Describe the composition of a compound and the answer to why can the properties of a mixture vary. It's good to go back and review our concepts. So I just put a little review in from those introductory concepts in section 1. Have a great day.